In this lecture, we're continuing our conversation about the amount of energy in a reaction and how a reaction proceeds and reaction rates. And here we're going to discuss energy and nutrition. So we typically determine the amount of energy in a piece of food using a calorimeter. And nutritionists will burn food in a calorimeter, and it'll measure the amount of heat that transfers from the sample into the water around it, this area here, which is stirred, and then you can measure the temperature change using a thermometer. And the idea is that you can transfer the heat produced by the sample to the water and measure that temperature change, which will allow you to calculate how much energy flowed from that sample into the water while it combusted. And so we can then use that temperature change to calculate the value of the energetic value of that food sample. So from these types of experiments, we have a general idea of the caloric or the energy value of food or types of food. And we can really break this down into carbohydrates, fat, and protein. And these types of food will have different amounts of energy per gram. So in 1 gram of carbohydrate, we'll see 4 kilocalories of energy that can be obtained from it. Or, I'm not sure what happened there. Sorry. 4. There we go. And so 4 for carbohydrates, 9 for fat, and 4 kilocalories for protein for every gram. You can do just a conversion where 1 calorie equals 4.184 joules and prove that if 4 kilocalories of a carbohydrate if carbohydrates produce 4 kilocalories, it'll be the same as producing 17 kilojoules of energy. Or for fat, 38, or for protein, 17. And so we can calculate, if we know the carbohydrate, fat, and protein makeup of a food, we can make a pretty good estimate of the amount of energy that that food contains using these as a calculation. So here's an example. We have a cup of whole milk. That's 13 grams of carbohydrate. And 9 grams of fat and 9 grams of protein, we can figure out how much energy is in the whole milk. And so for our 13 grams of carbohydrate, remember, that's going to be 4 kilocalories of energy that we get for each gram. So I'm going to set up a conversion factor where I'll have 4 kilocalories of energy for each 1 gram of carbohydrate in the milk. And if I calculate this by plugging it into my calculator, it'll be 13 times 4. I'll get the energy contribution from just the carbohydrate right here. So it'll be 52 kilocalories. Here, let's do this. Carbs, fat, and protein. So for our 9 grams of fat, we actually get more energy from 1 gram of fat than we would 1 gram of carbohydrates. We'll get 9 kilocalories for each gram. And so that should give me 81 kilocalories of energy from the 9 grams of fat in the milk. And then for protein, again, we get less energy. We get 4 kcals, just like our carbohydrates, for every 1 gram. So that's going to give us 36 kilocalories of energy. So to actually know how much energy a cup of milk will contain, I'm actually going to take these that I just calculated and add them up because all 3 are contained in the cup of milk. And so my 52 kilocalories plus my 81 kilocalories plus my 36 will give me 169 kcals of energy for 1 cup of milk. I'm going to stop our video there, and next we're going to talk about the energy of chemical reactions.